Alright, so we are looking at our 5.1 notes here, and we're going to go back into those sequence type of equations. So we'll bring back recursive and explicit, but this time they are geometric instead of arithmetic. Alright, so most automobiles depreciate. That means that they decrease in value as they get older. Suppose an automobile was originally cost $14,000. That should hint to you that it's A sub 0 because it's an original. A sub 0 equals that 14,000, and then we have to see what happens to each term. So the previous term times some value. So if it depreciates by 1/5 of its value, so it's going down by 1/5. That means that it's maintaining 4/5. Okay, and you want the equation to represent what it is maintaining. So 4/5, you can write the fraction in here, or you can change that into a decimal, which is 0.8. You're going to see decimals a lot, because we're going to look at percentages. So this would be 80%. It keeps 80% of its cost each year. So after 2 years, A sub 0 is our 14,000. Multiply that by 0.8 to get our first year. That should give us 11,200. And then do the same thing, multiply by 0.8. And our second year, you'll get 8,960. So after 2 years, the cost is $8,960. And yes, you need to write it in a sentence. Okay? Alright, when is the automobile worth half of its initial value? So half of that 14,000, so we're looking for 7,000. So let's keep going. A sub 3, so we're going to take 8,960, multiply it by 0.8, will give us 7,168, ooh, real close. And then A sub 4, so take this guy and multiply by 0.8, will give us 5,734.4. So somewhere in between here, we hit that 7,000. So between the third and fourth year, the car is half its initial value. All good? Alright. Not too bad. Sorry, my handwriting is really bad today. I apologize. Alright, let's try the next one. So between the third and fourth year, the car is half its initial value. Alright, couple terms to know. If you see half-life, so remember that when we do our equations, we have A sub n, which is like our y value. We have n, which is like our x value, and we have r, which is how much it's going up or down by, what we're multiplying by each time, our common ratio. Okay? So this number is what is going to get affected by our half-life. So our r value will be 1/2 in half-life, and you're going to see a function that looks like this, and we will get into what it means, x over 1/2. Don't stress too much about this, just know that half-life means r is 1/2 for now. In exponential function, there is a formula for it. If it's a function, it's f of x. Remember, that's the same thing as y. Your initial value, your common ratio, raised to the x power. So the key with an exponential function is that x is in the exponent. That's what you need to know. And then when we are doubling time, your common ratio, or in this case your b value, is going to be 2. So if we tripled our time, it would be 3. Alright? Let's sneak to the back of this. Alright, calculate the ratio of the second term to the first term and express the answer in a decimal value. State the percent increase or decrease. So what I would do is, before you even get stuck in your head, going from 60 to 51, I know that that is going to be a decrease. Okay? Going from 51 to 60, that is an increase. 25 to 40, we're increasing. And 40 to 25, we are decreasing. Okay? So when you're finding the ratio just means a fraction. Okay? So we're going to take the second term and divide it by the first term. So 51 divided by 60. This one will be 60 divided by 51. 40 divided by 25. 25 divided by 40. Because we want to know what we have to multiply 40 by to get to 25. So if we want to go backwards to find, we have to divide. Okay? So, this first guy should give you 0.85. Second guy gives you 1.176. Next one gives you 1.6. And the next one gives you 0.625. Alright, couple things to keep in mind. We're looking at percentages, so we're going to scoot the decimal twice. But because we're decreasing and we're increasing, we have to eliminate the 100%. So you have to subtract 100% from everything. Or in this case, 1, because we haven't changed it into percentages yet. So for this guy, I would do 1 minus 0.85. And that would give me a decrease of 0.15, which is 15%. This guy, I'm going to do 1 minus 1.176, which gives me an increase of 17.6%. 1 minus 1.6, increase of 60%. And this guy, 1 minus 0.625, is 37.5%. So I'm subtracting these guys. This gives me 0.375, and then I'm scooting the decimal twice because we're dealing with percentages. Okay? Not too bad. Alright, next one. Record 3 terms of the sequence and write the explicit function for the sequence. We're going to pretend that you know how to do this, because I know that you do, so it's not pretending. So 25 times 0.2 times 0.2 times 0.2 times 0.2. And I'm going to sneak and I'm going to give you the explicit formula. Are you ready for this? Here we go. A sub n equals, remember, explicit is the one that you can just plug in a number and get your answer. Substitute a number in and get your answer, excuse me. You are going to do your initial value times your ratio to the n. Oh look, there's my initial value. Oh look, there's my common ratio to the n, and boom, you're done. Same deal here. Start with 40 is my initial value. My increase here, or decrease, in this case it's an increase, is 1.6, so an increase of 60% to the n. That is it. If I had given you a sub 1 instead of a sub 0, or in this case u, you'd have to go backwards 1 to get this value. Okay? Alright. Next and last. In 1985, the daily cost of hospital care was $460 per day. Since then, it has increased by about 8.1% per year. So not only has it, if it maintained its cost, it would be 100%, but besides that, it's increased by 8.1%. So that is 108.1% that is going up each year, and we're going to change that into the decimal form. So our common ratio here is 1.081. So the 100% plus 8.1 more. That's how much more it is. So the recursive formula, and this is a very important statement, we're letting u sub 0 be the cost for 1985. 1985 is $460 per day. And what is happening each time, we're taking the previous term and multiplying it by 1.081. Okay? I'm going to sneak down to creating the exponential equation. So what we're going to do is I'm going to write the explicit formula and show you how easy this is. So remember, explicit formula, my initial value, 460, times my common ratio, 1.081, to the n. If it says exponential equation, we just change it into x's and y's. Or in this case, f of x, because it's a function, alright, and we need to define our variables. X is time in years, and y is the cost per day for the hospital care. Okay? So, I'm going to try and write sideways here. It's going to be a little bit goofy, so I apologize ahead of time. But this guy, our initial, is our 460. And then if you know the explicit one, you can just put it in your calculator and look at the table, which is why I skipped down to this one instead of multiplying by this each time. But you know what? I'm going to leave this for you guys to figure out. So you can either do it with the table, or you can do it by recursively, continually multiplying by this lovely number that I didn't mean to cross off, and I'm struggling with life today. Okay, there you go. Bye.